Hello, my name is Joshua Verboen.
It's your boy, Braden White.
And I'm David McCloud, and we're group number 2. And I'm going to be doing problem number 1. And so let's just get right into it. Alright, so the first step in problem number 1 is to define what an equilibrium is. And an equilibrium is a solution at which a differential equation basically flattens out. So on an ODE, in an ODE, if you draw a graph of it, the equilibrium are the points at which the slopes of any other solution will go to. No matter where you start, if the equilibrium, you will go to where the equilibrium is. All right, it is the solution to a differential equation. All right. So next we have to determine the equilibrium points by finding the points at which the slope, which is the derivative of this differential equation, is equal to 0. So this one's fairly simple. We start by just putting in our variables that we were given in the problem, and we get this to a point where we can solve for where x is equal to 0, or where the derivative is equal to 0. So alright. So we boil this down and it becomes, we just simplify it to a point that's easier to understand. 3 minus 3 over 4 x times 2 minus 1 over 4 x. Now our derivative, we need to set this equal to 0. And if we set this equal to 0, then when either of these two factors of this derivative are equal to 0, we are at 0. So we can basically set 3 minus 3 over 4x equals 0, and 2 minus 1 over 4x equals 0. And we will get x is equal to 12 over 3, which is 4, and x is equal to 8. All right, so now we have these 2 points. Those are the points on our phase portrait where our differential equation will be at equilibrium. So if we go to sketching the phase portrait, we'll just simply place these points on there. And we have to find what is happening in this equation to the point in between these points. So above 8, between 8 and 4, and then below 4. So the way we do that is, I'm just going to put this up here to make some space. We have to plug these numbers into, or numbers between here, into our differential equation with all the variables, and find the value that gives us. It does not really matter. It's just the sign of that value, whether it is positive or negative, because that in the derivative will tell us the slope of the equation. So we'll start with below 4. I'll just go with something easy like 0. 0 is a very easy number to work with. All right, and we solve this out, and the value itself doesn't really matter, but it comes out to 6, which is a positive 6. And so we know that below 4, our slope is going to be going up. So any value below 4 plugged into our equation, or our differential equation, is going to slope up to 4. And we do this again for between 8 and 4. And I'll use something easy like 5. And we can solve this out. And we will get this number will come out to be negative because this value comes out to be 15 over 4, which is greater than 3. And this value will come out to be, this is less than 2, so this value is going to be positive. And so this value we know will, because these two are being multiplied, it will come out as negative. So we know that between 4 and 8, our slope is going to be pointed down. And finally, we can go above 8. We'll choose something, once again, very simple. We'll go with 10, because 10's another easy number to work with. So if 5 was negative, we know that down here, this value will be negative, and this value will come out to be 10 over 4, which is greater than 2, so this will also be negative, and we multiply those, it is a positive value. And so we know that this is going to be going up. So above 8, we're sloping upward. Between 4 and 8, we're going down, and towards 4, and below 4, we're going sloping up towards 4. All right. That brings us to the last point on our problem, which is determining what is happening as x of t when t is approaching infinity. So as our graph goes along, we just draw another graph. If we draw the graph of this, we will get 0.4, we have 8, we have 4. We want to know, this is x, this is t. We want to know what is happening when, sorry, that looks like an x. We want to know what is happening if we start at t equals 0, if we are at a value of 6, which is right in between those two, where are we going to go? And we know from our phase portrait that if we are between 4 and 8, this value is going to slope down towards 4. So when x of t, as t approaches infinity, we are going to approach 4. And that's all the points of this problem.